Okay, to continue the lesson, previously we finished with just some hints to help you memorize XYR relations with the trig functions. Now, when you want to find the trig values of an angle, things that you must have always, always, always. One is the quadrant, where the terminal side of the angle is located at. The other one is the set of XYR must be completed. So if two of them are given to you, you can always put them into x squared plus y squared equals r squared and find the third one. In the quadrants, if you remember in maybe not the previous video, but the one before that, we already talked about if a point is in quadrant 1, then both its coordinates x and y are positive. If the point is in quadrant 2, then its x coordinate is negative, y coordinate is positive, and so forth. Something to keep in mind is that r is always positive. That doesn't change. Okay, now try to answer this question. If the terminal side of an angle is in quadrant 2, which one of its trig values are positive and which ones are negative? Well, here's the picture that I drew for you. So here's an angle theta in blue. Here's its terminal side. I just chose a point called P on its terminal side, and I'm looking at its coordinates x and y. And r, the distance from the origin to point P. Okay, so having this shape, now we see what? It's in quadrant 2. In quadrant 2, we know that x is negative and y is positive. We also know that sine depends on y, cosine depends on x. Why am I not paying attention to r? Because r is always positive. So if I'm determining the sine, S-I-G-N, of sine of theta, then it depends on the y coordinate of the angle of the point. Is it positive or is it negative? Well, we see that in quadrant 2, y is positive, therefore sine of theta is positive. Cosine of theta, we know that it's x over r, and r is always a positive value. So the sine of cosine of theta depends on what x is, if it's positive or negative. We see that in quadrant 2, x is negative, therefore cosine of theta is negative. Tangent of theta is a quotient of y and x. So its sign depends on y and x both. Y is positive, x is negative in the second quadrant. So if you divide a positive number by a negative number, the result is negative. So tangent is also negative. And consequently, you can talk about cosecant of theta being positive, secant of theta negative, cotangent of theta negative. So that's how knowing the quadrant helps us to know the sign, S-I-G-N, of sine, cosine, tangent, and the other three trig values of an angle. Here's an example. The terminal side of an angle theta passes through the point P with coordinates 8 and negative 15. Find the exact values of sine, cosine, and tangent of this angle theta. Well, remember that we said two things must always be complete. One is XYR, that set must be completed. Second, knowing the quadrant where this angle is located at. So in this case, I start by the point P that is given to us. And I see that its x coordinate is 8 and its y coordinate is negative 15. Knowing these, I write them here. So I already know x and y. Therefore, since x is positive and y is negative, this is located in quadrant 4. So here's the picture. Angle theta, starting from the positive side of the x-axis, it ends with this terminal side. Terminal side passes through the point 8, negative 15, which is this point P here. So therefore, we know the terminal side, so we know angle theta, which is this angle. Okay, good. Now that we know the quadrant, another thing to complete is the set of XYR. In order to find r, we already know x and y, so we put them in the formula. X squared plus y squared is r squared. We find that r is 17. The rest of it is just substituting numbers. We already know the quadrant, so we know the signs. We already know r. Therefore, sine of theta, remember that we were saying sine because if you extend I, it looks like the y axis. So it's y over r. Y is negative 15. R, we found it to be 17, so it's negative 15 over 17. Cosine of theta, remember that we said cosine, if you extend C, looks like x-axis. So it's x over r, and x is 8 here, so it's 8 over 17. Tangent of theta, we talked about this t, that's our hint, that's our clue. So t looks like y-axis, x-axis, so it's y over x. We have y and x, and we found that tangent of theta is negative 15 over 8. Here's another example. This one, a different way of giving you information. This one, the previous example, was pretty straightforward. It gave you the point, and then it asked you for the rest of them. This one, instead of giving you the point, meaning giving you x and y coordinates, it's giving you something else. It's saying that sine of theta is 3/5. So it's already telling you sine. And then it's telling you that the terminal side of the angle lies in quadrant 2. So the quadrant is given to us this time. Then it says find the exact values of the other 5 trig functions. Okay, fine. Let's focus on what we have. What we have is that here's the xy coordinates. We know that angle theta is in quadrant 2. So let's say this is our angle theta, since it's in quadrant 2. And what else do we know? This is the information that we have. We know that sine of theta is 3 over 5. Why is that helpful? Because we already know what sine of theta is made of. Here, remember that we said sine of theta is y over r. So the numbers that I have here, I set it equal to y over r. Now I can say y is equal to 3 and r is equal to 5. Numerator by numerator, denominator by denominator. So I have y, I have r. Now from the set of x, y, r, we are missing x. But we know how to find the relation. We know what the relation between the x, y, r is. X squared plus y squared is r squared. X squared we don't know. Y squared means 3 squared. R squared means 5 squared. Solving this equation, we find x squared is 25 minus 9, which is 16. Therefore, x is 4. So our set of x, y, r is complete. Now, something super important. Look here. After I write my x, I go back to the quadrant and I say, oh, this doesn't make sense. I'm saying x is equal to positive 4. However, quadrant is 2. So in quadrant 2, x is supposed to be a negative number. So what happened? What happened is this point. When we take square root of both sides, remember that square root always generates 2 answers, positive and negative. Now, quadrant tells us which one to accept. Since it's in quadrant 2, x is negative, therefore positive answer is not acceptable. Here I have to put a negative. So this is really, really important. That example shows you the importance of knowing the quadrant. Otherwise, you're just working with x, y, r, and every time you're going to get positives if you don't pay attention to this. Okay, so now that my set is complete, I work to find the rest. Cosine of theta, we know that cosine is x over r, x is negative 4, and r is 5. So that's that. Tangent of theta is y over x, y is 3, x is negative 4. Now we'll do the reciprocals. Here from sine of theta, I get its reciprocal, which is cosecant of theta, and that's 5/3. From cosine, I find its reciprocal, which is secant of theta, and that's 5 over negative 4, or just negative 5/4. And from tangent, I get its reciprocal, which is cotangent of theta, and negative 4 over 3. Or you can just put the negative at the beginning. So that's how everything works. So do remember that for these questions, you always have to know the quadrant. Ah, that's not the quadrant. Hold on. Quadrant, and complete the list of x, y, r. R always positive. X and y, they're positive and negative, depends on the quadrant. The relation between them that brings these three together, x squared plus y squared equals r squared.